There is a particular kind of military madness that occurs when engineers are given an unlimited budget, an impossible requirement, and a government that is too ideologically committed to the idea of overwhelming force to ask whether what they are building actually makes any practical sense. And the result of this specific combination of factors is almost always a weapon that is technically impressive in a narrow and largely useless way, while being operationally catastrophic in every way that actually matters when armies are trying to fight wars in the real world, rather than in the imaginations of the people who commissioned the weapon in the first place. Nazi Germany produced several weapons that fit this description with remarkable precision, but among all the oversized, overcomplicated, and fundamentally misconceived weapons that German industry produced during the Second World War, one stands out as perhaps the most complete embodiment of this particular form of military insanity. A self-propelled siege mortar so enormous that it required its own dedicated railway network to move from place to place, so heavy that it destroyed any road surface it attempted to cross under its own power, so mechanically complex that it spent a significant portion of its operational life broken down and awaiting repair, and so expensive to operate that each individual shot it fired cost more than most countries spent on entire artillery batteries. That weapon was the Karl-Gerät, and its story is a masterclass in what happens when military ambition completely loses contact with military reality. The origins of the Karl-Gerät lie in a genuine tactical problem that the German military faced in the late 1930s as it began planning for the kind of large-scale offensive operations that would eventually become the Second World War, because the defensive fortifications that France and other potential enemies had constructed along their borders were genuinely formidable obstacles that conventional artillery might struggle to destroy effectively. The Maginot Line, the elaborate system of underground fortresses and interconnected defensive positions that France had built along its border with Germany, represented the state-of-the-art in defensive military engineering, and German military planners looking at those fortifications had legitimate reasons to worry that standard artillery would not be sufficient to reduce them in the time available for offensive operations. What they needed, or at least what they believed they needed, was something capable of delivering an enormous explosive payload with enough accuracy to hit specific fortification elements and enough penetrating power to destroy reinforced concrete structures that had been specifically designed to resist artillery bombardment. The solution that emerged from this requirement was designed by the engineer Ritter von Eberhard under the direction of General Karl Becker, whose name the weapon eventually bore, and it was a solution that addressed the tactical problem of destroying heavy fortifications with considerable ingenuity, while simultaneously creating a set of operational problems so severe that they arguably outweighed any tactical benefit the weapon might provide. The Karl-Gerät was a self-propelled mortar, meaning that unlike conventional siege artillery, it carried its own propulsion system and did not need to be towed into position by other vehicles. But the term self-propelled somewhat overstates the mobility that this arrangement provided, because a vehicle weighing between 124 and 126 tons, depending on the specific variant, and powered by a 580 horsepower engine, could achieve a maximum road speed of approximately 10 kilometers per hour, and had an operational range of perhaps 60 kilometers before its fuel was exhausted, and its mechanical systems began to protest the extraordinary demands being placed on them. The weapon that sat on top of this barely mobile chassis was genuinely extraordinary in its destructive capability, a short-barreled mortar of either 600 or 540mm caliber, depending on the variant that fired projectiles weighing between 1,700 and 2,170 kilograms, which means that each shell fired by a Karl-Gerät weighed approximately as much as a modern family car and contained an explosive payload sufficient to collapse reinforced concrete structures that had been designed to survive direct hits from conventional artillery. The maximum range of the weapon was approximately 6,700 meters for the heavier shells and somewhat more for the lighter variants, which sounds impressive until you consider that conventional artillery of the same era could engage targets at ranges 3 or 4 times greater with nearly comparable destructive effect against all but the most heavily reinforced targets, meaning that the Karl-Gerät had to expose itself to enemy counter-battery fire at relatively close range in order to use the enormous destructive power that was its only real justification for existing. 6 Karl-Gerät units were eventually built and given individual names: Adam, Ava, Thor, Odin, Loki, and Zeus, a naming convention that suggested the German military establishment had a sense of drama even when producing weapons of questionable practical utility, and these 6 vehicles were organized into specialized heavy artillery units that were supposed to be deployed wherever the Wehrmacht faced particularly formidable fortifications that required the kind of overwhelming firepower that only the Karl-Gerät could provide. The logistics required to support even a single Karl-Gerät in the field were extraordinary because the vehicle was too heavy to cross most bridges, too wide to use most roads without causing severe damage to the road surface, and too mechanically demanding to operate without a large team of specialized technicians who understood its complex systems well enough to keep it running, which meant that every deployment of a Karl-Gerät required extensive advanced planning, route surveys, bridge reinforcement, and the pre-positioning of spare parts and maintenance equipment that added enormously to the logistical burden already placed on German supply lines. Moving a Karl-Gerät any significant distance required loading it onto specially designed railway flat cars, which were among the largest and most heavily reinforced railway vehicles in existence, and which could only operate on lines whose trackage and bridges had been certified to support the extraordinary weight involved. And the process of loading and unloading the vehicle from its railway transport and moving it the last few kilometers from the railway to its firing position under its own power was a time-consuming and frequently damaging process that often left the vehicle in need of maintenance before it had fired a single shot. The tracks of the Karl-Gerät were so wide and the ground pressure so enormous that the vehicle could churn through prepared road surfaces and leave deep ruts in soft ground that required significant engineering effort to repair, and the engine and drivetrain were stressed to their limits by the demands of moving such an enormous mass, resulting in a mechanical reliability record that was, to put it charitably, not what German engineers had hoped for when they designed the vehicle. The Karl-Gerät saw its most significant operational use during the siege of Sevastopol in 1942, where the 2 units deployed, Thor and Odin, fired a combined total of several hundred rounds at the Soviet fortifications defending the city, and the results of this bombardment illustrated both the genuine destructive power of the weapon and the limitations that prevented it from being the war-winning device its designers had imagined. The shells fired by the Karl-Gerät were certainly capable of destroying fortifications that conventional artillery could not reduce, and several Soviet defensive positions were demolished by direct hits from the enormous projectiles, but the weapon's slow rate of fire, which was measured in rounds per day rather than rounds per minute, meant that it could engage only a handful of targets during the time it took conventional artillery to bombard an entire defensive sector. And the mechanical problems that plagued both vehicles during the siege meant that they spent significant periods of the operation undergoing repair rather than firing at enemy positions. The fundamental absurdity of the Karl-Gerät became increasingly apparent as the war progressed, and Germany found itself fighting a different kind of war than the one it had originally planned for, because the static siege warfare against heavily fortified positions that had justified the weapons development and production became less and less relevant as Germany transitioned from offensive operations against prepared defensive lines to desperate defensive fighting against enemies who were advancing rather than defending. A weapon designed to destroy enemy fortifications was of limited utility when Germany was the one building fortifications and hoping they would hold, and the Karl-Gerät units found themselves being deployed in situations that exposed the full extent of their limitations, moving slowly and unreliably through terrain that their enormous weight and width made extremely difficult to traverse, breaking down at critical moments and generally demonstrating that the tactical capability to fire 2-ton shells at fortifications was not particularly useful in a war that had moved beyond the kind of siege operations for which the weapon had been designed. By the end of the war, the Karl-Gerät had become a symbol not of German engineering excellence, but of the specific kind of German military pathology that prioritized impressive technical specifications over practical operational utility. The same pathology that produced the Tiger tank, the Me-262, and numerous other weapons that were technically remarkable and operationally problematic. Weapons that consumed enormous resources and engineering talent that might have been better applied to producing larger numbers of simpler and more reliable weapons that could actually be maintained and operated effectively in the field conditions of a modern war. The 6 Karl-Gerät units met various ends, some captured by Allied forces, some destroyed by their own crews, and one preserved as a museum piece that allows visitors today to stand next to the weapon and appreciate, in a way that photographs cannot quite convey, the sheer physical absurdity of a machine that weighed 126 tons, moved at walking pace, and fired shells the size of small cars at targets that might have been more efficiently reduced by conventional means at a fraction of the cost and logistical burden. It was, in every sense that matters, the most absurd weapon Nazi Germany ever built, and the fact that it sort of worked some of the time, when it was not broken down, made it somehow even more absurd than if it had simply failed completely and been abandoned.